Hi, everyone. This is Jim Cahill with another Emerson Automation Experts podcast. We continue our Asia Pacific Sustainability and Decarbonization podcast series with a closer look at electrification, especially for batteries as an energy storage solution, and growing importance for the net zero emission goal in the region. I'm joined today by Emerson's Ryo Hashimoto to discuss electrification. Welcome, Ryo.
Hi, Jim. Thanks for having me on the podcast.
Well, Ryo, it's great to have you here with us. Let's begin by asking you to share some of your background and path to your current role with us at Emerson.
Thanks, Jim. Well, I joined Emerson Japan in 2004 and having several roles such as strategic planner, marketing, and business development. And back in 2011, I moved to Singapore as a product manager for analytical instrument covering Asia Pacific market. The role was serving something related to the sustainability and decarbonization. So that is something like starting my career of the sustainability and decarbonization, because the main purpose of analyzing water quality is for the health, safety, and environment. And during that time, I published several articles related to the water analysis, and some of them were picked up by you, Jim, in your blog post. So I'm really glad to back to this session and doing this session with you again. And then I'm back to Japan. And on the top of my main responsibility, I extended my responsibility to support sustainability and decarbonization initiative in Emerson Japan. And furthermore, I'm taking a role of supporting electrification business, mainly for battery and the Emerson sustainability and decarbonization business in Asia Pacific.
Yeah, I remember the blog post we did, and for our listeners, if you search on Ryo there, you'll come upon that post. So thanks for sharing your background with us. Let's get into it. What are some ways battery usage has advanced?
As you know, battery itself, especially for the lithium-ion battery, are nothing new to us. The technology itself was developed during 1980s. And the first commercialization was done by Sony in 1991, which is famous for the PlayStation, by the way. And since then, these batteries have applied in consumer electronics, computers, and other devices, and having been bringing a lot of benefit. For example, mobile devices powered by battery, such as smartphones, tablets, and laptops, allow us to work from anywhere and make us reachable to data and information literally anywhere and anytime in the world. So probably I can say that the battery is essential and critical product to sustain our business and private life. And now, under current carbon neutralization and net zero movement, the importance of the battery is increasing, mainly driven by two major energy segments.
Yeah, it's amazing the mobile world we live in now, all thanks to those lithium-ion batteries. In sustainability and decarbonization, the demand for batteries is discussed a lot these days, it seems. Can you elaborate what are the main drivers for battery usage in the energy mix?
Sure, I love to do that. As I mentioned, there are two major sources that drive in the battery demand. One of them is renewable energy, such as wind and solar power, that require energy storage for the stable power supply. And another one is the road transportation sector that is moving from internal combustion engine, aka ICE, to electric vehicle for all segments from the light duty to the mid to heavy duty vehicles. And according to a report published by the US Department of Energy in 2020, the battery demand share from EV will be around 90% in 2030, while from stationary storage application and consumer electronics will be 10%. The capacity demand itself varies based on the different scenario developed by the different parties, such as net zero scenario and stated policies, and so on. And actually, it really indicates that EV will be the main driver for energy storage capacity demand for the future.
Well, so what are actually required for battery capacity in 2030, and what is current deployed capacity? And I guess if there's a big difference there, how much is needed to ramp up battery production capacity?
Yeah, Jim, you were right. Actually, we really need to ramp up the production capacity. According to the IEA report, they reported that the battery capacity demand projection based on different scenario. I picked up two here. First scenario is stated policy scenario, which is based on the 7 major countries' stated policy. The battery demand will be 1,600 gigawatt hour in 2030. The capacity in 2020 is estimated 300 gigawatt hour per annum, and actual production was 160 gigawatt hour. So demand is expected to grow exponentially. And second scenario is sustainable development scenario that is assuming 30% of cars is EV. Then the expected demand will be 3,200 gigawatt hour in 2030. And this will be almost like 10 times of the capacity in 2020.
Wow, now that's quite an amazing increase required there. Can the battery industry meet the demand for the second scenario? And if not, what can be done?
Right. This is why what we are seeing right now are lots of announcement and news about investment from the battery manufacturers. According to the IEA and the Bloomberg New Energy Finance Report, when the plant manufacturing capacities published in the market are added together, the expected production capacity will be more than 3,000 gigawatt hour in 2030. So luckily, I can say the market demand will be able to fulfill the required demand by all the manufacturers if they are executed their capacity expansion as they planned.
Well, that's good. They're looking at the planning and where they think it's going to be in 2030, because that's a significant amount of additional battery storage that needs to occur there. So what are some of the technical trends in the battery market?
Right, yeah. There's a many technologies developing right now and still under developing. And as I mentioned at the beginning, the lithium-ion battery itself are not really new, and it is in the market more than decades. But the technology is actually really continuously improving. And currently what we are seeing is a three major trend in the market. First of all, when we look at EVs, the nickel, cobalt, and manganese, so-called NCM, is the major component for the cathode of the battery. The reason why NCM is popular in EVs is that because it can provide high energy density and stable charging and discharging characteristics. And when we look more on the NCM, depending on the share of the materials, it is called NCM 811, 622, and so on. NCM 111 means 80% of nickel, 10% of cobalt, and manganese respectively. The reason why for the higher nickel is because the nickel is important to provide energy density for the battery that will affect the total capacity of the batteries. And another reason for the NCM 811 is getting popular now is that because it can reduce the use of cobalt, which is rare metal and has limited supply. The second technology trend is LFP, lithium iron phosphate technology. The LFP has not been popular due to its lower energy density and charging speed. However, recently, cell-to-pack technology is developed in China and overcome those points and getting market momentum right now. The benefit of LFP is cheaper and not using cobalt at all in the cathode materials. Lastly but not least is all-solid-state battery and the sodium-ion battery. Both of battery is still in development or pilot phase and is needed to establish mass production technologies and method to be in the market. The benefit of all-solid battery is huge and higher energy density and lighter weight and less charging time and safe, and this is still going on. I wish we can have this technology ready now, but it is estimated to be commercialized sometimes late 2020s or even later.
Yeah, I was going to say there's always, something going on with the technologies. It's just trying to get them and produce them at commercial scale. That's always the challenge in there. And speaking of challenges, what are some of the challenges in the battery market?
It's a really good question, Jim. There are several challenges in the market, but I like to pick up one from them. It is about the minerals for the energy storage solutions. As I mentioned previously, the battery demand will be rapidly expanding to 1,600 gigawatt hour till 2030. And in order to produce that capacity, the demand for the lithium will see 8 times increase and 90 times increase in nickel and 4 times increase in cobalt and a 7 times increase for the graphite. The graphite is a main component for anode electrode. All of those minerals are mainly extracted in 3 to 4 countries. For lithium, lithium's from Australia, China, and Chile. And 3 countries account for 85% of the global supply. And looking at the cobalt is mainly coming from RDC, and RDC share itself is around 60%. And nickel is from Indonesia, Philippines, and these 2 countries account for 60 to 70% of total supply. And what I like to highlight here is that unlike oil and gas, the source of those minerals are very limited, and Asia plays key roles to supply those key minerals in the battery market. And as Emerson, we are supporting our mining and refining customers in Australia and China, helping their automation in the process to improve safety and efficiency of the operation. For instance, we are serving as a MAC, the main automation contractor for the several mining refining projects in these areas.
Yeah, that whole mining component is such a huge part of it to supply the raw materials to get into the whole battery production process. And it's great that we're playing a role to help make that process of the mining and processing of the minerals more efficient. So demand for metal components in lithium-ion batteries is one of the challenges. How about the price of the batteries? For road transportation, electrification, that cost has got to be a concern area.
Jim, it's a good question for that. According to the Bloomberg NEF report, the battery pack dollar value per kilowatt hour has been going down since 2010. The battery pack price per kilowatt hour was $1,200 in 2010 and now down to the $132 in 2021, which is around like 90% price reduction. And the trend for the cost reduction per kilowatt hour will follow for the next few years and expected to reach below $100 in 2024. However, due to the current supply chain issues and demand surge leading by China and some geopolitical issues and concerns, there is a price for the minerals. For example, the lithium price grew by more than 10% in 2022.
Well, it sounds like the technology and all the work going into it is driving deflation of it. But now we're faced with, because of demand for the raw materials, inflation going on with that. So I guess we'll have to see if hopefully the technology advancements can surpass the supply issues that we have here. What are some ways these challenges can be addressed?
Yeah, there are several points to mention here, but the interest of the time, I just want to mention 1 or 2 here. First of all, the technology development may help us to reduce use of those minerals, provide alternatives, or use nothing for those minerals. For example, LFP, the lithium iron phosphate, is one of those technologies not using those metals. And as I mentioned, new technologies such as all solid-state batteries and other types of the cathode will help to mitigate those risks. Another area we can think of is about recycling. Recycling of the battery minerals and metals are getting hot right now in Asia. Unlike fossil fuel, those metals and minerals will not lose chemical properties after use to the various degree, so it can be recycled. And I really want to deep dive into this topic, but this is our next electrification topic for the podcast. So let's discuss this in details in the next electrification podcast.
Now, I've done podcasts in the past specifically about mining and some of the Emerson technologies, from better managing the assets and increasing reliability and just managing the process around that. In some of these areas, as whether it's the recycling or whatever, are there any, just top of mind, a few Emerson technologies that are ways that we can help in the whole battery production value chain?
Right. Well, I mean, they say if I can pick up like the mineral minings and defining, and actually the recycling of the battery minerals and defining itself, they're almost like same process. And we are playing a lot of important role over there as well. Actually, one of the issues they may encounter is the equipment reliability in the areas. And we have full breadth of those like asset monitoring solutions in Emerson. We were helping them to continue and increase their availability in the process and operation itself.
Yeah, that's a huge area in that part of the process, just to keep things running reliably, and anything you can do to help predict problems before they occur and have the analytics get the right information to the right person for a decision that can really help there. And with the challenges you described about needing the production and what the growth and demand is going to be, those technologies are critical. So thanks for sharing that. And I guess just to wrap things up here, where can our listeners go just to learn more about this whole area?
Right. I think one of the areas you can tap on is visiting our website, and also like at least connecting to some of the other web pages we prepared for the S&D arena. At the same time, you can contact your local Emerson representative to get more information as well.
Well, Rio, that is great. You've really shared a lot about what's going on in the market, that increasing demand that's going to happen, and ways that we can help play a role in that. So thank you so much for joining us today and sharing your thoughts about this whole area of sustainability and decarbonization.
Thank you very much, Jim. I really enjoyed this podcast. Thank you.
Well, I did too. For all our listeners, this is another one in our Asia Pacific Sustainability and Decarbonization podcast series, and look for more to come in the series, and hope you all learn as much as I'm learning in the whole process. Thanks a lot, and bye, everyone.